Formwork and Rebbar secrets revealed. Learn how to avoid costly concrete mistakes. Before pouring concrete, every detail matters. In this episode, you will learn what you need to know about formwork and rebar, how to avoid common execution mistakes, and how correct installation ensures strength, safety, and long-term durability of your structure. After completing the excavation and reaching the required level, the soil must be properly compacted. A well-compacted soil provides a stable base for the foundation, reduces settlement, and prevents future structural problems. Only after checking the level, density, and cleanliness of the soil can we safely start with foundation works. This plan is composed of a main entrance that leads directly to the living area, which acts as the central space of the house. Near the entrance, we place the guest WC for easy access without disturbing the private zones. A storage room is positioned close to service areas to improve functionality and circulation. The bedrooms are located in the private zone of the plan, away from noise and public spaces, ensuring comfort and privacy. From a structural point of view, the column layout is a key element in this plan. Columns are positioned to align with walls and functional spaces, avoiding interference with circulation and room usage. Their placement follows a clear structural grid defined by axes. These axes organize the plan, control spans, and ensure that loads are transferred efficiently from slabs to beams and down to the foundations. Respecting column alignment and axes is essential during the structural phase. Any change can affect stability, increase costs, and create execution problems on site. A well-coordinated architectural and structural plan guarantees safety, efficiency, and long-term performance of the building. Before starting the structural works, a topographer must come to the site. His role is to transfer the axes from the approved plans onto the ground with high accuracy. These axes define the exact position of columns and foundations. Correct axis setting avoids execution mistakes and ensures the structure is built exactly as designed. On site, one simple formula helps us check if our axes are correct. A squared plus B squared equals C squared. This formula, known as the right-angle rule, allows us to verify that the angles between axes are exactly 90 degrees. By measuring the two perpendicular sides and then the diagonal, we can confirm accuracy. If the calculated and measured diagonal match, the axes are correct. This step ensures the building is positioned properly on site and prevents alignment problems during construction. Axes guide the exact position of columns and walls, ensuring the building is correctly aligned and stable. In reinforced concrete, the thickness or diameter of the iron bar directly affects the strength of the structure. Each bar diameter has a specific weight per linear meter, and this is why we always refer to the steel weight chart. Using this chart helps us calculate total steel quantity, control cost, and ensure the reinforcement matches structural design requirements accurately. For example, an 8mm bar weighs about 0.395 kilograms per meter, while a 12mm bar weighs around 0.888 kilograms per meter. Before comparing raft and footing foundations, let's start with a short introduction to footing foundations. A footing foundation is a localized foundation system where loads from columns or walls are transferred directly to the soil through isolated footings, combined footings, or strip footings. These footings are usually connected by tie beams or chainings to control differential settlement and improve stability. Above them, we may have a slab on grade or a slab on grid, which helps distribute loads, control cracking, and create a solid base for the structure. Now, let's move to raft foundations. A raft foundation is a single large, concrete slab that covers the entire building footprint, instead of transferring loads through individual footings. The raft spreads the loads of all columns and walls uniformly over the soil. Reinforcement is placed both at the top and bottom of the slab to resist bending moments. The concrete cover at the bottom protects steel from soil moisture, while the top cover protects it from weather exposure and ensures durability and structural safety. After the excavation is completed and the required level is reached, gravel filling starts. The gravel is placed in layers, usually not exceeding 20 centimeters, and each layer is properly compacted to achieve good bearing capacity and avoid future settlement. This process continues until the final level is achieved. Before starting any concrete works, a clean concrete layer of about 10 centimeters, known as blinding or lean concrete, is poured. After pouring the clean concrete layer, the horizontal waterproofing membrane is applied. This layer is very important because it protects the raft foundation from ground moisture and water penetration. Once waterproofing is completed, reinforcement works start. The bottom iron bars are installed first, following the structural drawings with proper spacing and concrete cover. Then the top iron layer is placed to resist negative bending moments. After that, column starters and wall reinforcement are fixed and accurately aligned. Before concrete pouring, we ensure the iron cage has sufficient concrete cover from both the top and the bottom. This cover protects the steel from corrosion and guarantees durability and structural performance of the raft foundation. Waterproofing must continue from the horizontal layer up to the vertical surfaces to create a complete tanking system. This continuous waterproofing protects the structure from water penetration from all sides. After finishing the waterproofing works, construction continues with the ground floor slab, followed by column execution, and then the ground floor slab, ensuring the building is fully protected and structurally integrated. We start slab execution by reading the structural plan and clearly identifying the axes on site, because accurate axes control the position of columns, beams, and slab spans. Once the axes are set, formwork installation begins, ensuring correct levels, alignment, and support. After that, reinforcement works start, placing the rebars for beams and slabs according to the drawings, with proper spacing and concrete cove. Structurally, the slab works together with the beams to transfer loads safely to the columns. In ribbed slab systems, also known as nervure slabs, the load is carried by concrete ribs while reducing the self-weight of the structure. Hordi blocks are placed between the ribs as non-structural elements, mainly to reduce concrete volume and overall weight. A minimum concrete topping of 6 centimeters is poured above the hordi blocks to create a solid slab.